Hi, within this lecture we're going to create our broadcast because as you can see we have finished the first step, which was the ARP request creation. Now we have to broadcast this ARP request in order to get the device's responses within the same network. So I'm going to use KP in order to achieve this once more, and I'm going to show you another instance, another class of KP. So let me create a broadcast packet here, and in order to do this I'm going to call KP once more, but rather than ARP I'm going to use a class called ether. Okay, remember the ether, it's related to MAC addresses. Okay, and once again let me do skp.ls to see the keyword arguments that we have to give or we may give once we create the ether instance. So let me save this and just run this. So since now I'm running skp.ls, I will see the output of the ether class. Yeah, as you can see now we have three sources in here. One is dest, source, and type. And this destination MAC field actually means that where we are going to send this packet, and the source MAC field is where is the source coming from, where is this packet coming from. And as you can see, destination MAC field has the value of FFFF for 6 times. So this FF actually means just send this to a broadcast. Okay, I mean it's going to broadcast this packet all over the network if we give this value, and it's already here. It's the default value of this dest MAC field, but sometimes it's not. It just changes according to the version of KP. Okay, so I'm going to write this FF thing manually in my code as well. But if I didn't write it, it would have turned out the same, since this is now the default value. But maybe the developers of KP will change this while you are watching this, so I'm going to write this manually in here as well. So what we are going to change is DST, the destination, and I'm going to write FF 6 times with colons, of course. And remember, this means that just broadcast this. And at this point I think we are ready with broadcast packet as well. And now we're going to send our packet, and in order to send our packet we need to combine these two requests into a one single request. Okay, so basically we are trying to send this ARP request packet. Okay, take this ARP request packet and send it to a broadcast, and we have this broadcast packet, and we can use kp.send method. Okay, and I'm going to show you that method in a minute, but we have to combine these two packets first. And KP has a very interesting way to combine these two packets, and you won't come across this kind of usage very often, and it looks a little bit confusing because we don't see it anywhere else, but KP just tells us to do it this way. Just don't be intimidated by that. It's really easy actually, but it's a little bit unusual. So what do we have to do in order to combine these two packets? We have to create a combined packet variable first. Okay, so you can call it whatever you want. I'm going to call it combined packet, and then you take the broadcast packet and put a slash and just do the ARP request packet later on. So we're combining this broadcast packet with ARP request packet, and this is actually related to the send method of the KP. And as you can see, it's very easy. You just put a slash between them, but we're not dividing them, we are combining them. So it's a little bit confusing in convention, but this is how it works, right? How do I know how it works? Of course, you have to read the documentation as I suggested before. So let me go back to documentation, and in here we have a send and receive packets method, SR method. Okay, so the function SRP talks about SRP and SR. So these two are send methods of SCAPI, and we have to use SRP to send two packets at the same time. And actually you can see the slashes and the combining thing in here in the examples as well. So if you pay a little attention here, you will see that this returns us a couple of packet and answers and unanswered packets. Okay, so we can actually see the answered and unanswered packets at the same time. Of course, we are interested in the answered packets because why? Because we want to get the real devices in a real network, and they will respond to the ARP request by saying that, yeah, I have that IP and my MAC address is this, and we want to pair these MAC addresses with IP addresses. So let me try this. So I will just use this SRP thing. So I will say scapy.srp, okay, and open a parentheses, and inside that parentheses I will specify my packet to be sent. This is combined packet, and I also need to specify a timeout, which is 1, which basically means that don't worry if you don't get an answer, just continue with the process, okay? And if I don't specify this, it will get stuck once it cannot find any answers to a specific IP. In order to keep things moving, I have to specify this timeout as 1 in here. So I think we are done right now. It will just create my request packet, and it will scan this IP range. Then it will broadcast my packet to all over the network in order to scan this IP range actually. Then I will just send it through using SRP methods. And as you remember, it will return us some packets. Let me just for right now print this, okay, in order to see the results, or let me just cast this to a variable called the results, then print this. Later on we will see how to process these results and show it to the user. So let me save this all and minimize this. Let me run my netscanner.py once again. And as you can see, it finished sending 256 packets, and it says that I have received 3 packets, I got 3 answers, and the remaining packets just stayed unanswered as expected, right? So we have the results here, we have the unanswered results here as well, but we have to dig a little deeper in order to show it to the user. So let's stop here and do that in the following lecture.